Hello everyone. Assalamualaikum and good morning. How are you?
Hello, teacher.
Hello, teacher.
Okay,
Salam.
Have you had your breakfast this morning?
yes, teacher.
Yes.
Very good, very good. I hope you guys are very motivated and energetic to start this class today. Alright, the topic is what I already mentioned in our previous class, which is the equation of Locus and the coordinate geometry. So I hope you guys already read my notes that I given to you guys from the previous class, and you guys are prepared, very well prepared lah for this class. Okay. All right.
Teacher.
So yes, this me.
Okay.
All right. Very good. This me looks so kacak today. Okay. Right. So before we begin, I would like to share with you guys our learning outcomes for today. So by the end of our session today, you guys will get this some of the skills needed for this subtopic, right? So the first one is to represent graphically and calculate the equation of locus that satisfy the conditions below. Right. First is the distance of a moving point from a fixed point is constant. Second is the ratio of a moving point from two fixed points is constant. And next, also to able to solve problems involving equations of loci. See, so this is what you guys will obtain by the end of our session today. Right. So yes, before we start, also I would like to highlight that there are three sections in equations of loci. If you guys are wondering what loci is the plural terms of locus. Locus is singular, loci is the plural. Right? So first is locus of a moving point from a fixed point is constant. Second is the ratio of distance of moving point from two fixed points is constant. And the third one is the solving problems involving equations of loci. Right, so these three sections we will cover throughout the whole class today. And I also provide example for each sections, and I hope you guys are very much excited as well as me to do the example with me together. Okay, class?
Teacher.
Yeah, right. Good, very
Yes.
good. Yeah. Thank you, Aina Samani and Hidayat Amira. Alright, so just like any other topic before, we start with a definition and a question. What is equation of locus? Right, so what is equation of locus? Right, so by the definition, I also have prepared a concept for you guys to have a better understanding about the equation of locus, but I will proceed with the definition first. So locus can be defined as the path taken by the point subject to a certain conditions. So it's stated here that there will be 2 points. It involves the distance between 2 points, and you can say the path taken between one point to another point under a certain conditions. These conditions we will go to later in the three sections that I mentioned before. And equation of locus is the equation of a moving point. Right. So inside the equation of locus topic, we have a moving point for two conditions. And the equation of locus that we want to find is the equation of that moving point. Right. So I hope you guys will have no problem so far. You guys have any questions regarding the definition? No,
Not yet,
Not
teacher.
yet, sir.
not yet. Very good. Right. So if you have any problem, just tell me and just raise your hand. I'll try my best to help you guys. Right. So we go with the first section. Locus of a moving point from a fixed point is constant. So what is it and how does it work? Right. So as you can see, before we proceed with the definition by the words, let's proceed with the concept first. So as you can see at the left, there is a radar. Can you see the radar? All right. So have you ever wondered how does the radar works?
Yes.
Not really.
Okay, that's okay. I will explain to you guys about how does radar works. So basically, the applications of radar much used the equation of locus itself, because the radar have a center point, which is at the center of the radar, and it has a radius, a constant radius that's circling the center, and also it has a coordinated point. This coordinated point are the point that will enter the radius of the radar and will be notified by the radar to the receiver. Right? How does it similar to the concept of the equation of locus? Right. So as mentioned before, the equation of locus is involving a moving point, right? A moving point. So if a moving point P, let's say, have a distance of 5 between P to A, and only P is moving, when P is moving at any point, it will form a circle, right? It will form a circle. Right. So that is why the concept of equation of locus for this first section is very much similar with the concept of the radar. Right. So you guys get the concept, the ideas that I'm trying to explain to you guys?
Yes, teacher.
Yes, sir.
Very good, very good. So by the definition, it exists only one point from the locus of point. This is what you need to remember. It exists only one point from the locus of point, which is the moving point. One point with constant distance from center point to the locus of point. So in this situation, we will have a center point that is fixed at its place with a coordinate. And we have a locus of point, which is a moving point that will circle the center point with a constant radius. Right, so for a better explanation and a better understanding for you guys, I already prepared a slide for you guys to see. All right, this is the concept that I'm trying to show. You will have a moving point. In this situation, it is P. P is the moving point, and it is moving around the point A. Right, point A is coordinated by x1 and y1. Okay, it could be 0, 0, 1, 0, 4, -3, and so on. It depends on the question. So A is the coordinated point, a center point with coordinates, and P is the moving point. So between A to P, it has a constant distance of R. And so this distance between A to P and P to A is R. So no matter where you put P, whether it's up here or down here, or at the left or at the right, it will have a constant distance. So that is why at any point, when P is moving, it will form a circle around the center point A. Do you guys understand?
Yes, sir.
Very good. Do you have any questions regarding this concept? No, right. Right, very good. So since the constant distance between point P to A denoted by R, therefore we can assume that PA is equals to R. Right. PA is given by the formula square root of x minus x1 to the power of 2 plus y minus y1 to the power of 2 equals to R. Okay, so x1 is the coordinated point, x1 and y1 is the coordinated point at A, while x and y is the point of P. So at any point P, it will be noted by x and y, and at point A, it will be denoted by x1 and y1. Right, so we will proceed with an example for you guys to see. Right, this is the first example. Find the equation of locus of moving point P so that its distance from point A for -3 is 6 units. Okay, so as I mentioned in our previous class, the first thing that we have to do when we get a question is to extract important points. Right, remember? Right, so
Yes.
yes, very good. Thank you, Bismi. Okay, there are three important points. There are three important points in this equation of locus. In the first section, which is you have to know what is the moving point, what is the center point, and what is the distance. Right. So in the equation, it is stated that what is the moving point is P. P is the moving point. Yes. So what is the center point? Center point
A.
is A. Yes, true. 4, -3. And the distance is
6
unit. All right, very good. 6 units. So first of all, when you guys get a question, you need to sketch it on the graph. Right, you need to sketch it. So 4, this is 4, negative 3, this is the coordinate of A, and you can get 6 units from A, 1, 2, 3, 4, 5, 6. Then you will get P. So P could be at here at the right or at the left or at the top or at the bottom, anywhere. But it must be 6 units from the point A. Right, so how you guys want to answer it? So remember the equation given it is the square root of x minus x1. So x1 is 4 to the power of 2. So you put it 4 here plus y minus y1, which is y1 here is negative 3. You put negative 3 in here and to the power of 2 equals to r. R is the distance, which is 6. All right. So 6 here, you can eliminate the square by transferring it to the right side, and you will have this equation x minus 4 to the power of 2 plus y plus 3 to the power of 2 equals to 6 to the power of 2. You can expand the equation, then you will get this equation, and you will get equals to 36x to the power of 2 minus 8x plus 16 plus y to the power of 2 plus 6y plus 9 equals to 36. Clear so far, students?
Yeah.
Alright, very good. So you transfer this 36 value to the left and you eliminate any possible terms that can be eliminated, then you will have the final equation. So for equation of locus, you don't have to define the term whether it x equals to y in terms of y or y is in terms of x. You don't have to do that. Just have to put it everything to the left side and equals it to the 0. Then you will have the final equation, just x to the power of 2 plus y to the power of 2 minus 8x plus 6y minus 11 equals to 0. Right. So you have any problems so far? No. All right. Very good. All right. Very good. Thank you. Thank you, Aina. Everything clear? Then we will proceed with the second section. Right. About the second section, the ratio of distance of moving point from two fixed point is constant. Right. So this is the concept at the left. Imagine that you are in an aeroplane and passing through above cities, and in order for the aeroplane to avoid colliding with any buildings, it will have a system that will trigger it. How far the distance between the aeroplane and the buildings around. So in this concept, in this equation of locus, it's very similar with, it's very similar with the concept that used by the aeroplane in passing through and above the cities. Right, by the equation, by the definition, right, this is the difference between the first one and the second one. The second one, you will have 2 points from the locus of point. It exists when there are 2 points from the locus of point. Just now, when there are only 1 point, but now there are only 2 points from the locus of point. Then same like previous one, it has a constant distance of the 2 points from the point of locus. Right, but in this section, the difference is we don't use distance in determining the equation of locus, but rather we are using ratio of the distance. Right. So I will show you guys in the example. Before we proceed, I would like to ask you guys, do you guys have any problems regarding the concept, the second section? No, very good. So, right, this is the concept that I want to highlight with you guys. So, this, let's say we are having a point P. P is the moving point, and we have first point A, and we have a second point B. So when A to P, it have a distance of M. This is a constant distance of M, and P to B have a constant distance of N. Right. So when P to A, it have a constant distance of M, and P to B have a constant distance of N, then we need to ratio the distance of A to P and B to P. So by the equation, we can put it here, PA is equals to M and PB is equals to N. But since we need to ratio the the distance, then you will get PA over PB equals to M over N. So M over N is the ratio of the distance. Okay, it's not exactly the distance, but the ratio of the distance. So if you have a distance of 4 to 2, what is the ratio?
4-2. 4-2.
So actually the ratio is 2:1 because you can divide 4 and 2 with 2. So you will have 2:1. Okay. Right.
Okay, sir.
So I hope you are clear with this concept. So the equation is not much different. It's still the same, but we are using a different writing in the formula. So as you can see, this is a little bit problem because my computer mistakenly generate it and it cannot revert it back. So you can focus on the below equation of Locus formula here. You can get x minus x1 to the power of 2 plus y minus y1 to the power of 2 over x minus x2 to the power of 2 plus y minus y2 to the power of 2 equals to m to the power of 2 over n to the power of 2. Right, so x1 and y1 is the coordinate of the first point, while x2 and y2 is the coordinate of second point. X and y is still the same, the coordinate of p. Okay. Right. So how does m2 over n2 here exist? It is because of the square here. When we try to eliminate the square, we transfer it to the right, then we will get m to the power of 2 and n to the power of 2. Okay, can you guys understand? All right, very good. Do you have any problem or any questions?
Oh, teacher.
Very good. Then we will proceed with an example. All right. So, example is much simple, I would say. I'm sorry. This problem is really, this laptop is really noise me. All right. So, example, find the equation of locus of moving point P such that its distance from point A to 3 and point B 69 are the same. Right. So, as usual, what we need to do is to extract important point. So, can you guys tell me what is the moving point
P.
at point P? All right. What is the center point?
A and B.
A and B. All right. So the distance is M and N. But since it's mentioned here that the distance are the same, so the ratio M and N is
Same.
1:1. Yes, it's the same. So it is 1:1. Right. So this is the method to solve it. So you need to draw here A to 3, B 69, and you will get this sketch of the graph. So in this concept, you need to do it TA over TB equals to 1 over 1. And since TA over TB is equals to 1 over 1, then you can put TB up here, then you will get TA is equals to TB. All right. So then you will have this equation square root of TA equals to square root of TB. And you can eliminate the square by transferring it whether to the right or to the left. Then you will have left with TA only and TB only. Right. So you can expand the value here, the bracket here, and you will get the final equation. Right. So this is the final equation: ax plus 12y minus 104 equals to 0. Right. So do you guys have any questions so far? Under the second section. Right, no. Right, very good. You guys are very clever because you can snatch it quickly. Right, so what have you learned? This is kind of reflection. I want you guys to write it on the paper and please upload it in our Padlet so I can get what you guys have learned so far after these two sections. Right. So the third one is solving problems involving equation of locus. This might be a very quick one. Right. So a goat is tied with a rope to a pole which is planted in the middle of the field. The length of rope used is 4 meters. The goat walks around the pole tied to the end of the third rope as shown in the diagram. If the coordinates of the pole are 2, 4, find the equation of locus of the goat strap. So in here it gives us a distance. So if we have a distance, what are the concept of the equations that is used? is the first one,
Fine.
right? The first one. Okay, and it have a coordinated here. So this is the center point, and it have a moving object, which is the good. Then the good will be our moving point.
Moving point.
Yes, very clever, Bismit. Thank you. So this is the picture that you can sketch. The distance of 4 meters, and the good is moving around the pole of A with a coordinate of 2, 4. So since we have these important points here, then we can do the calculation. We can put it the good as P to the A with a distance of 4. So you can denote it, you can write it here as PA equals to 4. Then you can enter the equation square of x minus negative minus 2 to the power of 2 plus y minus 4 to the power of 2 equals to 4. You can eliminate the bracket, and you left with PA equals to 16, 4 to the power of 2. And you can expand the bracket, and you will get the equation. After that, you can eliminate the important things, and you will get the final equation. Right. So can you guys understand so far?
Yes.
I assume that you don't have any questions regarding this part. Okay. No. Alright. So this is the sketch on the graph that I made for you guys, just in case you guys are wondering how. So basically it's the same. Distance of 4 units and the coordinates of 2, 4. And the equations also, you can see it's the same equation. Right. So you guys can try to sketch after this. Right. So we are moving on to the last part, which is the summary of the lesson. So I would like to give you guys a brief summary of locus of moving point. It have three parts, which is on the first section, when the distance is constant from fixed point A, involves of 1 point only, then we can have this kind of equation. Right. So when the second concept, locus of moving point P x y, which distance is constant from two fixed points A and B, is always constant in the ratio of mn, is this equation. You have to do the ratio. So you have the PA over PB equals to m to the power of 2 over n to the power of 2. And the third one is when locus of moving point P x y, which distance is constant from two fixed points A and B, is the same. So the ratio of 1 to 1, then you can bring PB above, then you have PA equals to PB, then you will get this kind of equation. Right. So you guys have any other questions regarding the topic? No. All right.
Sir.
All right. Thank you. So since you guys don't have any questions, that's basically about our topic for today. So I leave you guys with some exercises. Please look at page 205, practice 7.4, question number 1, 2, and 3. Please answer all the questions and submit your answer in our classroom Padlet. You guys have the link to our classroom Padlet, right?
Yes. Sir.
Last submission is 4 days later. So today is 17, perhaps by 21, your answers already in our Padlet. Right. Right. So
Yeah.
that's basically it. This is some reference I prepared for you guys. You can visit these few websites and this additional textbook. So if there's nothing, so I would like to say thank you very much for participating in my class, and have a good day and have a good weekend. So thank you, my students. Bye bye. Assalamualaikum.